This is the Unit 8 review, Part 2. We're starting with problem number 11. It says find the volume of the following composite image. All right, so we can see that this shape on the top is a hemisphere. And so volume of a hemisphere. And so it's just going to be half the volume of a sphere. So it's 1/2 times 4/3 pi r cubed. And then the shape on the bottom, of course, is a cylinder. And that is just base times height, where the area of your base is a circle. So it's pi r squared times height. We can see that the radius is going to be 6 because it is half of the diameter. And the height is 13. So my volume is 1/2, times 4/3 pi times 6 cubed. And we'll put that into the calculator. I'm just going to go ahead and work out the pi. I know on the first part I gave you both answers, but for the decimal answer, it's going to be about 452.39. And this is in inches cubed. And we're going to add that to the volume of the cylinder. And so the volume of the cylinder is pi times the radius squared times the height. And that's going to be pi times 6 squared times 13. And that is approximately 1,470.27 inches cubed. We're going to add these two together. And the total is going to give us approximately 1,922.65 inches cubed. In problem number 12, it says write the equation that can be used to find the volume of the following figure. So this one's not asking us to actually solve it, just write the equation. All right, so on the top we have a cone. So this is volume of a cone, and that is going to be 1/3 base times height, where the area of the base is a circle. So it's 1/3 pi r squared times height. And then we have volume of a cylinder. And that is going to be base times height, where again the area of the base, pi r squared times h. Okay, so my equation, 1/3 pi, the radius we can see on our figure is 7. The height of the figure, the height of the cone is also 7, and so that's going to be 7. And then we're going to add on to that the volume of the cylinder. So pi times 7 squared times the height of the cylinder now is 6. All right, and so my volume is equal to this. I can kind of clean this up a little bit, but I don't need to. I can leave it like this. Number 13, what is the volume of the following composite shape? All right, so what we've got here is a cube, and then we have a cone that's like carved into it. So we need to find the volume of the cube and then subtract the volume of the cone. All right? And so the volume of the cube is base times height. And so the area of the base, length times width, that's going to be 6 times 6 times 6. Because all of the dimensions on the cube are the same. So then we're going to subtract, the volume of the cone. And the volume of the cone is 1/3 pi r squared h. All right, and so this would be minus 1/3 pi, the radius. Okay, so we can see that on the cone, the diameter is 4. Diameter is 4, so the radius is going to be 2. And then the height of the cone is the same as the cube, so that's times 6. All right, so let's go ahead and plug that in. And then I'm going to take this over here. And let's see, 6 times 6 times 6 minus 1/3 times pi times the radius squared times the height, and that is approximately 190.87, and this is centimeters cubed. All right, and number 14, we have a toy company has designed a playhouse with a tunnel attached. The marketing department wants to advertise the size, find the volume of the playhouse. All right, so we have the volume of the cube, and we know it's a cube because all of these measurements are the same. And then we have the volume, let me just, which is base times height, which is going to be volume of the cube. Oh, hold on, sorry about that. I'm just going to go ahead and start setting this up. 5 times 5 times 5 plus the volume of a cylinder, which is base times height, and this time our area of our base is a circle, so pi r squared times h, and we can see that the radius is equal to 2, so plus pi times 2 squared, and then the height, it's shown right over here, that's going to be times 3. All right, so this is what goes into your calculator. And this is approximately 162.7 feet. Volume is cubed. All right. In problem number 15, it says we have a rectangular prism with a volume of 30 feet cubed. Find the volume of one of the dimensions was tripled, a second dimension was doubled, and a third dimension was 5.5 times. Okay, so the volume, let's think about this. Let's see, we have, find its volume if one of the dimensions was tripled, so that's going to be 3 times. A second dimension was doubled, that's 2 times. And a third dimension was 5.5 times longer. All right, so if our volume is 30 to start with, we're going to take our volume and multiply by all of these dimensions. So it's going to be 30 times 3 times 2 times 5.5, and that's going to give me 990, and this is feet cubed. Okay, and number 16, the height of a cylinder is increased, so it is 4 times as tall as the original. So my new is 4 times what my old was, okay? And that is just straight from here. The height is increased, it's 4 times as tall as the original. What is the ratio of the new to the original? So the new to the original, it's 4 to 1. And number 17, it says, look at the pattern of the cylinders below. If the pattern continues, which would be the correct setup to find the volume of the next cylinder? All right, so let's find the ratio. See if I can zoom in a little bit. I'm going to go ahead and take some of these easier numbers. I can see that the ratio of the diameter is 3 to 2. Let's take a look at the ratio of the heights. We have this height to this height, so the ratio of the height is 6 to 4, which reduces to 3 to 2. So we know that the increase in the diameter and height is a scale factor of 1.5. Okay, in problem number 18, what would be the effects of the surface area of a cube if the length of the edges is multiplied by 4? Okay, so this is what we're multiplying by, and we're talking about area. Area is units cubed, so it would be 16 times larger. Okay, what would the effect of the volume? Volume is units cubed, and so 4 times 4 times 4 is 64 times larger. And number 20, the volume of a pyramid is 136 inches and the height is 24. What is the area of the base? Okay, so volume on a pyramid is 1/3 base times height. And we know the volume is 136. The height is 24. We need to solve for the area of the base. Well, if I multiply 1/3 times 24, that's going to give me 8. If I divide both sides by 8, the area of the base is going to be 136 divided by 8, and that's going to give me 17 inches squared. 21, the volume of the cylinder is 1215. Okay, so volume is base times height, pi r squared times height. And we know this is 1215 pi. The diameter is 18. Well, the diameter is 18, so we know that the radius is half of 18, so we know that's 9. So it's going to be 9 squared. Question says, what is the height? And so that's what we're trying to figure out. If I divide both sides by 9 squared pi in my calculator, 1215 divided by 9 squared, the height is 15, and this is feet. 22, we have an ice cream snack company is designing a new package in the shape of a cone to replace a cylindrical shape currently in use. The cylinder holds approximately, okay, so the cylinder is 452 and has a lid with a radius of 6. So R is equal to 6. So volume of a cylinder is pi r squared times h. We know it's 452.16. And the r is 6. We need to figure out what the h is. So if I divide both sides by pi times 6 squared in my calculator, pi and the 6 squared will cancel. H is going to equal what this is, 452.16 divided by pi divided by 6 squared. So we know that the height is approximately 4. It's about 3.99. All right, so now let's find the volume of the new conical shape package that contains the same height. Okay, so volume of a cone. All right, so we know that this is going to be 1/3 pi r squared h. We know that the height's going to be the same. And the radius on the lid is going to be also the same. So it's going to be volume is equal to 1/3 pi. The radius is 6 squared times 4. And let's see what that is. 1/3 times pi times 6 squared times 4 in the calculator. The new volume is 150.79. So it is much less than that cylinder.